Hello friends, welcome back to my YouTube channel. This is Assistant Professor Ramdas Pandit. In this video lecture, we have to continue previous topic, that is titration of strong base and weak acid. Now in this video lecture, we have to see when we are adding the base into the acid, at times at every stage, how will we change the pH, that we have to calculate. Okay, now in the first stage you will see without addition of base, whatever you will take the solution for the calculation of pH. And we know one thing, the acetic acid is a weak acid, right? So that pH will be near about 7. Okay, less than 7. Okay, but near about 7 will be. Okay, now acetic acid is a weak electrolyte because it cannot dissociate completely. Okay, so if you will take the 25 ml of zero point 0.1 normal acetic acid in conical flask, so that times what will be the pH for this kind of solution, and we have no, it cannot dissociate completely. Okay, so the value for the dissociation constant for the acetic acid, that is constant value, you will see here 1.75 into 10 raised to minus 5. Okay, so we will see how acetic acid is dissociating CH3 C double OH. The concentration is given, we have taken here, and CH3 C double O minus plus H plus. So this is the dissociation of these molecules, right? And this is at equilibrium stage. And you will arrange like this for the dissociation constant, that is CH3 C double O minus, okay, the concentration of H plus, okay, divided by CH3 C double O H. Okay, now in this way you can say here, the since X is very small, 0.1 minus X. Okay, and we will arrange in this way, 1.75 into 10 raised to minus 5 is equals to x square divided by 0.1. So next step is x square. We will arrange like this, x square is equals to 1.75 into 10 raised to minus 6 molar. And next step we will calculate directly H plus, concentration of H plus ions, that is 1.313 into 10 raised to minus 3 molar. So from this value you will calculate the pH, and that is 2.88. So without addition of base into the acetic acid at the first stage or start of the titration, so the pH will be 2.88, right? And the next step we have to see at the next step, that is when you are adding 7.5 ml 0.1 normal NaOH to the 25 ml 0.1 normal acetic acid. So what will be the pH, that we have to see. So we have to arrange in this manner. Okay, 25 ml of acetic acid and addition of base, that is 7.5 ml. Okay, so you will subtract here, the remaining part is 17.5 ml. Okay, and we have no equivalence point, that is you can see here 25 ml we have taken acetic acid and only 7.5 ml of base. So remaining part, that much 17.5 ml is reacted. Okay, acetic acid is remain unreacted, that much volume is unreacted. Okay, so And what will be the new volume if you are adding that much solution? Okay, 25 ml into that 7.5 NaOH. So total volume is 32.5 ml. So that will be the new volume. So you will arrange like this. We have know this formula N1 V1 is equals to N2 V2. This is for old. Okay, N1 V1 is for old and new. This is for N2 V2. Right. So we have to arrange in this way, and you can put these values. Concentration, old concentration, that is zero point 0.1 normal, right? And we have to find out the new concentration. Normality, that is, you can say it is a concentration, right? So the old volume is 17.5 for the acetic acid. Okay, so this side for the acetic acid. Okay, and you can see here N2 and V2. So left hand side is for the unreacted acetic acid. Okay, and this side is total mixture of this solution, base and acid. So in this way you can arrange for this equation. So you can calculate the next step, that is N2. Okay, in this way you can calculate and you will get 0.05384. That is the normality. So it was the concentration for unreacted acetic acid. Now we have to see the neutralized part. Okay, how much neutralize? You can see the reaction acetic acid plus NaOH. Okay, right? So in the product there will be formation of salt and water here. Okay, and we have know the concentration of this. Okay, neutralized water or reacted, you can say acetic acid. Zero point 0.1 normal we have taken, and that much volume. NaOH 0.1 normal, concentration is the, okay, and 7.5 ml. This is the reacted part with the acetic acid. So 7.5 ml of volume NaOH is reacted with the 7.5 ml of acetic acid. Okay, so same volume. That's why we call here neutralized part of acetic acid. And you can see salt. The concentration 0.75 is given. Okay, now we have to calculate the molarity of sodium acetate. Okay, so how will you calculate the sodium acetate? So you will take like this formula, and we have to put some values of this. Okay, millimoles of salt divided by the total volume in ml, right? So in this way you can put this value. Millimoles of salt we have taken here 0.75 divided by total volume is 32.5. After calculation you will get that much value, that is the molarity of sodium acetate. And according to the formula of acidic buffer, hydrogen ion concentration, or that is we call them pH, right? So you will take this formula in bracket H plus is equals to Ka in brackets acid divided by in bracket salt. Okay, what is the meaning of bracket? We know that the concentration of acid divided by the concentration of salt. So you will put these values. Ka is the constant value that we have no 1.75 into 10 raised to minus 5. This is the constant value for the acetic acid, dissociation constant, right? And the concentration of acid that we have already calculated. So you will take, okay, 0.05384, okay, and divided by the salt concentration, this, okay, 0.02308. So after the calculation, you will get that much value, that is 4.082 into 10 raised to minus 5 molar. And you will take this value into the pH formula, you will get that much value. That is the pH is 4.39. Now, next step, that is when you are adding the 10 ml of zero point 0.1 normal NaOH to 25 ml of zero point 0.1 normal acetic acid. So what will be the pH? Okay, so that we have to calculate. Again, we have to arrange like this. Okay, 25 minus 10. So you will get 15 ml. That is the volume of unreacted acetic acid, right? And the total volume is 25 plus 10. 10 volume for base and 25 is the same, okay, for the acetic acid. So the total volume is the 35, and this is, we call them new volume. So same we have to arrange like this, old and new, N2 V2 or N1 V1 like this. And you will put these values in this way: zero point 0.1 into 15 is equals to N2 to E5. You will arrange in this way. After that, you will calculate N2. That is the concentration of unreacted acetic acid, right? Now we have to see the neutralized part of acetic acid for this step. Again, we have to take simple reaction. Okay, acetic acid zero point 0.1 normal is concentration into 10 ml. Okay, and zero point 0.1, this is the for NaOH, and you will get here 1 millimole for the salt. So we have to calculate the sodium acetate molarity. So in this way you can take again, okay, the concentration of sodium acetate and is equals to millimoles of salt and whatever total value in ml. So in this way you can put these values: millimoles of salt, that is 1 given here, and total volume is 35, right? 35 is equals to, after calculation you will get that much molar concentration of this salt. And according to the formula of acidic buffer, you will take simple this same formula, that is the concentration of hydrogen ions is equals to Ka, concentration of acid divided by concentration of salt. So you will take the same value again, this is the constant value for the acetic acid. Okay, 1.75 into 10 raised to minus 5, and the concentration of acid is, we have calculated already. You will take this value, okay, 0.04286 divided by the concentration of salt. This is, we have to take from here, okay, that is 0.02857. And after the calculation you will see here the pH will be 4.581. So in this way we have to calculate when it is unreacted acetic acid and it is reacted with the base. So that time how will be the pH that we have seen. And next stage, okay, that is the first stage. Now we have know the equivalence point. When we add the same volume, same strain, same concentration of the solution in each other, then that time we'll get equivalence point. When we have to add like this same amount, so you will get only salt. Okay, salt will be present in the solution. So you will take the simple reaction same manner. Okay, acetic acid 25 ml, zero point 0.1 concentration is there, normal concentration, and for this is for the NaOH, this is for the salt, that is 2.5. So you will calculate the molarity of sodium acetate. Okay, how much millimoles of salt is given, that is 2.5. Okay, we have taken here same formula, that is millimoles of salt divided by the total volume in ml. So in that formula we have to put this value 2.5 millimoles of salt divided by the 50, that is the total volume, right? And is equals to, you will calculate the 0.05 molar of sodium acetate. And in this step, how will you calculate the pH for this stage? That we have to see now. The formula is given for the calculation of the pH, that is 1 by 2 pKw plus 1 by 2 pKa plus 1 by 2 log C. So we have know what is meant by pKw and what is meant by pKa. Okay. So kW, the value is given, that you can see here 1 into 10 raised to minus 40. And when what we have require here pKw. So you have to take simple minus logarithm of this value. Okay, so you will take minus log 1 into 10 raised to minus 14. So you will get the 14 plus 14 value. Okay, now we have to see the pKa. Okay, the Ka is the value is given 1.75 into 10 raised to minus 5. Again we have to take the minus logarithm for this value. So you will get 4.756. So both value we have to put in this equation and you will calculate the pH. Okay, and in this way you can calculate. Okay, pH is given, so you have to take this 14 from this. Okay, and 4.75 from this, and the log C, that is the concentration. Directly we have calculated here, we can directly put into this here. So the next step you can calculate, from this step you will get 7, and from this step you will take 2.3785 minus that much. Okay, so after the calculation you will get that much pH. pH is equals to 8.728. Now we have to see the next step, when you are adding the 26 ml of zero point 0.1 normal NaOH to 25 ml of zero point 0.1 normal acetic acid. So what will happen that times, okay, how many volume we have added? 26 of NaOH and 25 of acetic acid. That means what will happen? The 1 ml is extra of NaOH. That means NaOH is remain unreacted. Okay, so in this way you can see again 26 plus 25, the total volume will be 51 ml. So that will be the, we can consider as a new volume. So again we have to see in this way. And what will happen here? 1 ml is extra from the NaOH. That means the OH minus ions are extra in this solution. So first of all we have to calculate the OH minus ions. That means the concentration of OH minus ions, and you can calculate in this way: millimoles of OH minus ions divided by the total volume in ml. So you will take simple 0.1 into 1. 1, this is extra now, divided by 1. After calculation you will get that much value, 0.00196 molar. So in this way you can calculate the concentration of OH minus ions, right? And this value you can put into the POH formula. That after that you will get POH 2.7077. And when we have to calculate the PS, so that value you can put into this formula and you can calculate easily pH, that is a 1.292. This is the pH. Okay, when we are adding the 26 ml of base 0.1 normal sodium hydroxide into the 25 ml of 0.1 normal acetic acid. Okay, so you will get that much pH right? Now the last step, that is when we are adding the 30 ml of zero point 0.1 normal NaOH to the 25 ml zero point 0.1 normal acetic acid. So what will be the pH or OH minus ions? So in this way we have to write, okay, 30 minus 25 is equals to 5 ml. So the 5 ml is extra from the NaOH. Okay, that means the NaOH remains unreacted, right? Again, the new volume you can see here, 30 plus 25 is equals to 55 ml. So we have to take again same formula for the calculation of OH minus ions. Millimoles of OH minus ions divided by total volume in ml. So you will take these values is equals to zero point 0.1 into 5 divided by 55. After calculation you will get 0.00909 molar. So that is the concentration of OH minus ions, and this value you can put into the POH formula. You will get POH, right? 2.0414. Okay, and for the calculation of the pH, we have no this formula we have to use, and after rearrange you will get that much pH. Okay, this is for the last stage. Yes, that is 11.959, right?